I think we'll go ahead and get started with the afternoon session. For those of you who are here this morning, welcome back. And for everybody else, I think we've got an equally fascinating PM session today. The first speaker that we have is Richard Patten, who is president of Raven Aerospace Technology, which is an engineering services organization. And he has worked with, previously, before he went out on his own to conquer the world on his own, which I salute. Worked with Oceaneering Space Systems, where he worked in the early design of the ship he's going to talk about today, the Kelly Astroliner. He also worked in certifying the Orbital's Pegasus launch aircraft, and as somebody who flies on the Pegasus regularly, I'm thankful that he had that role. He's done space commercialization studies for NASA, nuclear weapons site remediation, and is also conversant in a variety of space robotics projects. His topic today is Kelly Space and Technology Business Overview, and he's going to present yet another one of the emerging commercial space planes. So, Richard, welcome, and we'll look forward to hearing your presentation.
Thank you. Good afternoon, ladies and gentlemen. I'm Richard Patten, president of Raven Aerospace Technology. It's my great pleasure to speak with you today on behalf of Kelly Space and Technology, a firm with Raven has a great history. Raven Aerospace is a Houston-based company that provides a variety of engineering design services to aerospace and commercial high technology industries. We were recently part of Kelly's team for the NASA Space Transportation Architecture Study out of NASA headquarters, and on that we were responsible for human rating analysis and engineering as it applies to reusable space launch vehicles such as Kelly's Astroliner. Over the years, we have also been closely involved in the overall design of the Astroliner, in particular payload accommodations, environmental control, ground processing, operations, and life support systems. Now I'm going to start talking about Kelly guys. Kelly Space is an emerging and reusable spaceflight vehicle company that is in the process of building a business that will enable the servicing of any satellite plane virtually on any day from almost anywhere around the globe. Kelly Space is a 6-year-old company that was founded by Mike Kelly and Mike Gallo, two former members of TRW's Strategic Missile Systems Division. And these people that built our ballistic missiles over the years. At TRW, Mike Kelly conceptualized and designed a vehicle that has since been taken to practice in the form of Lockheed's Athena launch vehicle. In the course of his analyses, Mike realized that space launch could be accomplished substantially less expensively with vehicles that operate more like aircraft, that do not depend on expensive and complex launch sites, which for the most part are reusable. It's part of that vision that I will describe today. The Astroliner is a fully reusable space launch vehicle designed to safely and reliably deliver approximately 85,000 pounds of expendable upper stage and satellite to reference circular orbit of 100 nautical miles with a 28.5 degree inclination. This equates to 10,500 pounds or more of net payload to that destination. This is a very large, fully reusable vehicle piloted by a crew of 2. It operates using turbine engines during subsonic flight and 3 Russian NK-33 engines during its ascent to the space environment. The vehicle may be operated from any 10,000 foot or longer runway and can land on short runways upon return from its satellite launch mission. Very little ground infrastructure is required in support of the vehicle. In fact, the ground support is very much akin to that required for any routinely operated cargo class aircraft. The vehicle operates using liquid oxygen and kerosene for its rocket engines and uses the same kerosene with its gas turbine engines. At this point, I'm going to bring the concept to life through animation. And get synced up here for the voice overview. Standard airport hangar facilities are sufficient to service the Astroliner, with the addition of facilities sufficient for payload processing. Setup can be easily and inexpensively replicated at a number of key sites around the world. As you'll see momentarily, the Astroliner is towed like a powered glider to its launch site of 20,000 feet. A modestly modified Boeing 747 is used to tow the Astroliner to its predetermined launch site. 747 also serves as a flying launch operations center, the upper deck having been modified to include consoles for monitoring the Astroliner upper stage and satellite. Satellite will have been pre-integrated with the upper stage along rapid loading into the Astroliner cargo bay. The Astroliner operates its turbine engines to contribute thrust, increase the payload, and to safeguard against 747 power loss during liftoff and ascent. The Astroliner is equipped to quickly dump propellant and improve its flight characteristics in case it has to abort. Now it's at its 20,000-foot launch site. The specific mission to be performed, it ignites its 3 rocket engines, shuts down the turbine engines, drops the tow cable, and begins its ascent to an ultimate altitude of 600,000 feet. Ascent involves approximately 4 Gs of axial and 1.5 Gs of lateral acceleration. At 300,000 feet, the rocket engines are shut down. Coasting to about 400,000 feet, the nose door opens just like a C-5. The upper stage and satellite combination is deployed from the cargo bay. The excitable upper stage, in combination with its satellite cargo, now forms an autonomous multiple burn satellite injection. Deploys the satellite and sends return the atmosphere to burn up. The Ashliner begins re-entry similar to the shuttle, with 2 key differences. First, it did not go to orbit, so re-entry velocities are approximately 1/3 of the shuttle. And second, it has lower wind loading than the shuttle, thus resulting aerothermal loads are approximately 1/8 that of the shuttle, enabling the use of lightweight, readily available, and durable thermal blankets, which are affixed to someone's skin. And he's left. Restart it. Oh, where is it?
Did you say it's got a bigger wingspan than the shuttle or smaller?
It is 90-foot wingspan, and it's about 120 feet long.
How does that compare to the shuttle?
It's a little bit larger than the shuttle, but it also weighs a lot less. Its dry weight is only about 120,000 pounds compared to about 240 for the shuttle.
And that's why you use the other.
Well, that plus that it doesn't go all the way to orbit. So the combination of the two gives us, the low thermal loads.
Does the bigger size help grab more air? Slow down?
Yeah, it increases your lift during the re-entry process.
Good.
And while it's a combination, it increases your lift to drag ratio, but it's a classic aircraft wing loading and its overall weight compared to how much the wings are trying to lift up against that. Yes, yeah, guys, we're good. Although this one's really long, I'm penny at home. Let's see. What I would have been saying at this point, Ashliner through hypersonic maneuvering can achieve approximately 500 nautical miles of cross range. Then once it is again operating subsonically in the atmosphere, it reignites its turbine engines. And at this point, that provides with the ability to operate in the atmosphere like any other transport class aircraft. And the kerosene that's reserved for this portion of the flight enables about 500 nautical miles of distance. Let me go ahead and advance to the next one. So this shows it's a little more statically. And so essentially, same thing we're just doing the animation, but now you can see it in profile. A couple key points I want to point out. First of all, notice that the Ashliner is able to safely abort intact any time during its ascent flight profile. And now where pilots can intervene when either the Ashliner has developed a problem or telemetry indicates an unhealthy condition of the upper stage or satellite. Up to the point of deployment, the satellite cargo can be returned to Earth for launch on a subsequent mission. And actually, what we like to think of, that these are not really aborts as much as the equivalent of an airliner doing a diversion. That we don't have to do any fancy reboost, complicated high G turns, essentially shut the power off, it's a wings level glide forward until you get back subsonically where you kick on your turbine engines again, which are highly reliable, and then from there you fly into this runway instead of that runway. So it's basically doing your same profile, not doing anything new and unproven. For a normal flight, from point of rocket engine ignition to your touchdown, it's full flight time will be about 30 minutes, assuming that you're not, you don't decide to reposition the vehicle somewhere else at the end of the mission. Only a short duration of that is under rocket powered flight, so essentially it's operating like an airplane for most of its life. It flies with jet engines. Also, another key point is that this start point here can be anywhere in excess of 1,000 nautical miles from the point where you take off. That the capacity of the 747 to tow the vehicle gets you that far. You can also reposition your initial starting point. Depicted here is a Florida-based high inclination launch scenario. It could just as easily be a Texas Gulf Coast launch towards Florida, a West Coast launch, or almost anywhere else around the globe that suits the needs of the customer and the orbital objectives that you set up for the plane you have to go to optimize the performance.
Is this a suborbital flight?
Of the Ashliner, correct.
What's the longest orbital suborbital flight today?
The nominal it does from that point to that point is 750 nautical miles, which is downrange distance. And then you get 500 nautical miles off to the side. And the apogee goes up to 600,000 feet.
I guess that could be done at the equator also, help satellite launch further.
Right. Yeah. The mission that we depicted here was for doing space station servicing as part of the transportation architecture study that we recently did. So there we were going up to the 51-degree inclination the station's at. But like I said, we could come back over here and launch due east, and from right off of Texas, and then come back and land in Florida. That's the flexibility is one of the key points of this concept, and the range you get. And so you either base your start point for the orbit you're trying to get to, or your customer requires you to be near where their operations are for taking off from. So, combination of those. Thus the phrase, any satellite plane from anywhere on Earth, any day.
Question, has, I guess, Kelly addressed the FAA's concern with towing aircraft through controlled airspace?
Yes, and the majority of the operations, and especially initially, are planned to be over water. Initial test flights will be out of Edinburgh, and that are already working with the Air Force and the FAA for all those approvals. And as long as we're only deploying an expendable upper stage, the operation is going to have to be over water. Because the way that works, if it doesn't ignite, it's going to fall down somewhere. So you've got to be over water for that portion of your operations in order to ensure public safety. Once we can develop a reusable upper stage, then it's technically conceivable to then go to overland operations, so regulatory approval is going to take a while.
Well, to get the best in terms of basing options, that was the question I was asking. For example, if you wanted to operate out of Texas, what would be your concerns? Because most of the airports on the coast are already real thick with commercial airplanes anyway.
Well, for instance, Ellington Field is a prime candidate. It currently is it's only an 8,500-foot runway, but they've got plans to extend that as part of the National Guard support. So that it's become a very viable candidate right out of Galveston Bay and into the Gulf.
Thank you.
And as I said, Kelly feels the main technical consideration is going to be the staging process. That up till then, there's enough safety considerations built into the vehicle that you should eventually be able to operate in normal FAA airspace. All right, this slide lists some of the key technical points of the Ashliner. As mentioned before, it's a large vehicle. It has 700,000-pound gross takeoff weight. The cargo bay is a diameter of 18.5 feet with a length of 45 feet. There's a crew of 2 pilots, additional seat for payload observer. Rocket engines use liquid oxygen and air-seek propellants. High-performance gas turbine engines are used during takeoff and in-atmosphere powered flight. The F414 engines are the ones that are used in the F-18E. As said before, nominal down range is 750 nautical miles, and the ground range is 500 nautical miles. And the extended upper stage will also use liquid oxygen and kerosene. By design, Kelly's business diligently avoids reliance on technologies that are not yet developed or very early in their maturity. Everything seen in this depiction exists today, and in every case, individual components or subsystems have been fully qualified on other applications. This characterization, leading-edge concept built of trailing-edge technologies. The vehicle's airframe uses traditional airplane construction techniques and materials. Materially, the vehicle surface is covered with lightweight thermal blankets, which are manufactured by Oceaneering, another local Houston-based company. And these are currently being qualified on the X-34 program. Not easily seen the picture of the vehicle's gas turbine engines, which will either be embedded in the wing roots or placed in convertible pods below the wings on either side of the fuselage. Weight and balance, EG control, etc. are managed by distributing the kerosene tanks throughout the fuselage. Said accommodations are planned for crew of 3, although only 2 pilots are required for the majority of flights. As I was saying, essentially every piece of the Ashliner and its expendable upper stage system has been previously qualified under flight conditions. Obviously, only after the first Ashliner has been assembled and begins flight testing will the various components come together and operate as a full system. A number of interested parties have been somewhat doubtful about the ability to tow a 700,000-pound airplane with the Boeing 747. Therefore, in conjunction with the Air Force and NASA's Dryden Flight Research Center, Kelly Space performed a 6-flight demonstration test series to address the tow of a hypersonic flight-configured space launch vehicle behind a large, aerodynamically messy 4-engine transport class tow aircraft. The QF-106 is used to simulate the space launch vehicle, and a C-141 performed the tow. And you can sort of see here that they've got the back cargo bay doors open, and what essentially with the tow hardware is mounted on a standard pallet, bolted into the cargo bay, and flagged with the doors open like that, thus increasing the messy weight behind the vehicle. And similar to the plane operations, the Astronaut, the 106 had its engine running the whole time in an idle configuration, which also happened to give it hydraulic power to run its actuators for its flight control surfaces.
How much did the 104 weigh?
The 106?
Yeah.
I probably misquote if I try to give you a number off the top of my head at the moment.
Wasn't any 700,000?
No, it's not. It was set up as a scaled flight, and was importantly part of what NASA contributed to the project was extensive modeling and simulation of the tow flight dynamics. So then through the flight test, we were able to verify that, and actually one of the interesting things they did was recalibrate the quoted drag coefficients of the F-106, because that had never been, they never had the instrumentation at the time to fully verify that to the degree that they had modeled in this simulation. So now that we've got that modeling capability, we've been able to work with the scales and go to this weight. The demonstration was completed in early 1998, highly successful, generating much useful data on the dynamics of aerotow. Accomplishments were recognized by the U.S. Small Business Administration with the Tibbetts Award, signifying the best small business innovative research effort for the year. And there's recently an article in NASA Tech Briefs about some of this work, and I believe on the Dryden website they've got some fact sheets about some data that they've developed. Company plans to design, develop, produce, and initially operate 2 Astroliners. You see in the schedule, beginning revenue service is planned for early 2003. This schedule, it should be appreciated, is entirely paced by the ability to raise the necessary capital with which to move ahead. Start date, obviously, is completely tied to having the funds to move ahead, and will slip accordingly if funds aren't raised. We'll come a little further on the status of financing in an upcoming chart. Flight testing will involve a series of flights. See down here at the bottom of the chart, that all of which will be piloted, and which will gradually increase the flight performance envelope of the vehicle. So take a little step each time until you've worked out all the bugs of the system, and will culminate in a full simulation launch of a payload to orbit. As you can see, the Astronauts are produced in serial, thus allowing lessons learned from the first flight vehicle to be incorporated into the second, and also minimizes cash flow demands. The baseline plan is based on these assumptions for launch frequency, 14 flights per year per Astroliner, with a nominal 3-day turnaround, assuming a standard 8-hour workday. This can be compressed if required for a call-out mission. The flexibility embodied in Kelly's operating concept and design will ensure that these flight rates are achievable, even if a single Astroliner providing service for an extended period of time. And the slide illustrates the expected market for the satellite launches. This was an estimate developed by KPMG. There's the FAA estimate floating around from last year, which predicted a lot more than this, and various other organizations have made their own predictions. By design, they purposely have discounted a number of payloads that are known to be planned and are financed, preferring to take a position of market entry conservatism. Blue columns, at the bottom, a little trouble seeing them, represent the portion of the market that they plan to capture. And they also have planned in a ramp up of that market share to, again, show conservatism to the expectations of the investors. And not surprisingly, as I'm sure you've heard from everyone else today, financing is the biggest challenge. Capital requirements are on the order of $500 million. To date, the company has raised slightly less than $10 million, so much remains to be done. The company, for the most part, is a commercially focused, privately financed corporation, and it serves the interests of potential government customers and the developmental needs of the company. Certain technology elements the company will compete for and perform government contracts. As I said at the outset, recently the company won and performed one of 5 space transportation architecture studies on behalf of NASA headquarters. And this study was not an Astroliner-specific study. Instead, it focused on production of a total architecture to facilitate inexpensive, highly reliable, and routine logistics support and human access to the International Space Station. Mission requirements were achieved by an Astroliner derivative vehicle and the addition of a reusable transport vehicle carried over it by the expendable upper stage. This gave us transport to and from space of the people. More details of this study are available on NASA's website, actually at the headquarters website, I believe. On a closing night, on a closing note, I invite you to visit Kelly Space and Technology's website at www.kellyspace.com. And for any questions that I'm unable to answer to them. The company is located in San Bernardino, California. They welcome your questions and comments. I've also listed the phone number here if interested. To this point, we have to take any questions.
2 questions. What's your payload bay diameter and who's building your upper stage?
The payload bay diameter is 18.5 feet and it's 45 feet long. And who is building the upper stage is a question open to negotiations at the moment. The baseline has been the Soyuz 3rd stage, but there's obviously other companies that are interested in doing that, and as Kelly's looking for strategic partners, that decision can easily change. That using the Soyuz as is off the shelf, it carries performance penalties over what is theoretically possible. So if someone else wants to step up and build it, they're welcome to talk to them.
Are these only suborbital flights?
Of the Astroliner vehicle. For the transportation architecture study, we had put a reusable derivative of the CRV vehicle on the front end of the expendable upper stage, and that went all the way to orbit to station and then returned. So it could become a 2-stage to orbit fully reusable system. The next step would be almost fully reusable if you still expend the upper stage, but eventually that could conceivably replace that with the reusable stage.
And if it
potential for use as a overnight delivery system?
Certainly there is. Saw Chuck Lauer's presentation this morning, saw how he had laid out somewhere, that instead of the trajectory I showed here is a very lofting trajectory, trying to get up as high to send the upper stage on its way. So you can stretch it out to do overnight deliveries. Whether or not you want to use that exact same vehicle configuration for that or not hasn't been fully looked at yet.
Where do the pilots sit?
And this configuration shown here, they're in the bubble just in front of the tail. As this design goes through iterations where we've looked at moving that forward, it's similar to like the upper deck on 747, seeing that forward above the cargo bay. It's not cast in stone yet.
Isn't that if building on this building on
Yes, it would. And that's one of the trade-offs that's being worked. The time it was placed there, looking at a lot of the research from the National Aerospace Program for the video-based landings, which they did enough flight tests in that program to show that was indeed feasible. So it's viable. Obviously, a pilot would prefer to have windows whenever possible. So that's why we're looking at other options.
Thanks very much.